Simple Atwood machine. The Atwood machine is going to be any situation where a force is caused to change direction with a pulley or change direction without any loss of that force. So you can have tables with pulleys on them or cliffs with pulleys on them, anything like that. We're going to just go the very most simple kind of Atwood machine, which will be where you have just one pulley and you're going to have a string over one side of that pulley and you're going to have one object, and then you're going to have over the other side another object. So you have your two objects. There's the pulley. The pulley's frictionless. I'll put a little axle point in the middle of that. Frictionless pulley and massless pulley. And no physics is involved in this thing. We don't have to do anything with the pulley. We'll say this is going to be 8 kilograms. And we'll say that this is going to be 12 kilograms. Okay, so those are our two masses, which means that we're going to have downward force here, we're going to have a downward force there, that'll be 80 newtons. This will be 120 newtons. And what we need to decide is how we'd like to attack this question. There's a lot of different ways. There is doing it on the Atwood machine, where we actually leave it here and we just go with this force is down, this force is down, and we have to figure out who moves up and who moves down. We're not going to do that. We're going to do, well, let's actually define what the question is first. We're going to find the acceleration of each mass and the tension. And there's only one tension because there is only one string attaching the two of them. First thing you're going to do, and it's the first thing you're going to do all the time with any kind of a pulley question or any kind of a question where you have two different directions or a two-dimensional question, is we're going to turn it into a linear situation. So what we'll do is we'll have the 12 kilogram here, we're going to have our rope in between, we're going to have the 8 kilogram there. Because of the fact that the pulley doesn't actually do anything except change the direction, we'll just get rid of it. The 12 is going to be pulling this way at 120 newtons, and the 8 will be pulling this way at 80 newtons. There's no frictional forces because there's no surfaces on these things, so it's really just two forces. So the second thing we'll do is we're going to do our sum of our forces. There is only two. Let's figure out which direction it's going to go. It's going to go this way, so I'll make that my positive direction, which might cause you some grief because actually the 120 is pulling down, so you might like to call this negative. I don't know. Actually, I'm just putting the positive here to show you which direction it is, and then I'm going to show you a totally new way of actually labeling your final answer. But we'll go 120 is going to be added to minus 80 equals mass times acceleration. So 120 minus 80 is going to be equal to 8 plus 12 times my acceleration. 40 equals 20a, so your acceleration is going to be 40 divided by 20, so that gives you an acceleration of 2 meters per second squared. So that is your answer. But how are we going to state this? We've got an 8 kilogram mass, we've got a 12 kilogram mass. If you go back up to here, they're both going in two different directions. This one's going up, this one's coming down. So you could say the 8 kilogram mass, I have space here so I'll use it. You could say 2 meters per second squared up. For the 12 kilogram mass, you could say 2 meters per second squared down. Obviously we could have just put our positives and our negatives. We could have said this one's positive and this one's negative. You could have done that as well. Or you could introduce the idea of a clock. 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. There's your clock. And look at what actually this is doing. It's going around this way, which is clockwise. So you're swirling in this direction. That's what this is doing. So you could also just call these things clockwise, clockwise. Okay, that could be how you do it as well. So clockwise, CW, that's clockwise. And CCW is counterclockwise. It really doesn't matter to me how you write it, positive, up, down, clockwise. Just be able to recognize the fact that sometimes you'll see things indicated in terms of clockwise and counterclockwise. Third thing we need to do, we need to find our tensions. Our tension is just on this string here, so you can figure it out by looking at this. That's your situation right there. You're going to have the object being pulled this way by the tension, so tension. 80 is in the opposite direction that you want to go. Mass times acceleration, so tension minus 80. Oops, you couldn't see any of that. Tension, I'm doing my sum of forces here. Okay, my tension is in the opposite direction of my 80. So tension plus negative 80 equals mass times acceleration. So tension minus 80 is going to be equal to the 8 is what's being moved, so 8. And the acceleration, the one that I have here, it's going to the right, so I'm going to throw a 2 in there. So tension is going to be equal to 8 times 2 is 16 plus 80. So your tension in that is going to be 96 newtons. There you go, 96 newtons. That is right here, 96 newtons. Again, it doesn't matter. 96 newtons. This is one rope, so it's tension here, tension there. There you go.